All right, we're going to look over problem solving with permutations. And this was the title from the one we messed up before. Here's our question for permutations. How many different characters can international code? So international code is like Morse code. It's just what they use today. How many different characters can international code represent with 1 to 4 pulses? Okay, so this concept here is that there are 4 different pulses. We have, we'll call it pulse 1. Maybe he's short. Pulse 2, a little bit longer. Pulse 3, longer than that, just for simplicity's sake. I don't actually know what they are for. Maybe one's like a dot dot or something like that. But there's 4 different ones, okay? So we have 4 different pulses. And how many different characters can international code represent with 1 to 4 pulses? Because there's 4 different pulses, and we're going to choose them 4 different times, we're going to be using a permutation. So a permutation is done with this formula here. NPR is equal to n factorial over n subtract r, whatever that number is, factorial. The n is the number, I'm not sure what the wording is they use, but the number of characters in this case. Characters, okay? And in our case, we have 4 characters. And the r is the number you want to select, number you want to select. So we're going to say in this question that they decide to select it. You have the option of selecting it 4 different ways, 3 different ways, 2 different ways, or just 1, right? For instance, think of this idea. I could say in Morse code 1, 2, 3, 4. So pulse 1, pulse 2, pulse 3, pulse 4, and maybe that's the letter Z, okay? But I could also say pulse 1, 2 is the letter C. Okay, so for Z I used 1, 2, 3, 4 pulses, but for C I only used 2 different pulses, right? And then you also have the option of like pulse 2, 2, or you could just say pulse number 4 represents A. Like there's many different ways to go about this. So what this question is actually several permutations added together. Okay, so the first permutation is we have the 4 characters, and we're always going to have 4 characters to choose from. That's going to be our n value, so n is 4. And our r, in our first example, is the number you want to select. Well, let's see the number of different characters when we're choosing all 4 of them, okay? So we're going to do r is 4. So in other words, we go 4p4, okay, is equal to, and it'll say 4 factorial over 4 subtract 4 factorial. 4 subtract 4 factorial is 0. 0 factorial is 1. So this ends up being just 4 factorial, which is, I think, the number 24. Now your calculator will probably do this, and we'll do it. I'll show you on the calculator we can do that. So that's our first option. We've done 4p4. Okay. So we took the 4 characters and we're choosing them 4 times. So that's like the idea of we went 1, 2, 3, 4. That represents Z. Or we go 1, 3, 2, 4. That represents Q. Or we go 4, 3, 1, 2, that represents 8. But we're always using 4 characters, okay? So we have the number 24. We also have the option of 4. Again, we always have the 4 characters. But this time, we only choose 3 of them, let's say, okay? So we go like 1, 3, 4. That represents the number 3 or something. How many different ways can we arrange that? That will give you 3 factorial over 4. Nope, sorry, 4 factorial over 4 minus 3 factorial. I wrote that wrong. Okay. And that actually ends up giving you the exact same answer as before because 1 factorial is the same as 0 factorial. Okay. So using that idea, we're just going to go all the way down. 4p2, what does that equal? And 4p1. Okay, so if we were to choose just 1. So let's take our calculator out here. I actually have that option here. I can do a permutation, okay? And I just got to put the numbers in. So let's do 4p2, and there are 12 options that way. And finally 4p1, so I'll just click this and then just replace that number with 1 is equal to 4. And that makes sense, right? If you only have one number to choose, you either have the number 1, the number 2, the number 3, or the number 4. So the number 4. So we've gone through all the many different ways, which means if these are all possibilities, we need to add each of these together to figure out the total possible number of characters. So you're looking at 24 plus 24 plus 12 plus 4, which is 48, 50, 60. I believe the number is 64. So there should be 64 different ways that we could arrange these 4 different pulses when using a max of 4, I guess, characters in our letters. Okay?